Hello, in this video I will go over factoring by grouping and when to use grouping by factoring. So yeah, we're learning about factoring by grouping. So factoring by grouping is another technique that only works with only four terms, nothing more or nothing less. So for example, you have 2x cubed minus 3x squared minus 2x plus 3. As you can see, there is exactly four terms, right? This is one term, this is another whole term, another, and then another. So that's total four. If you have anything less or anything more, you can't do grouping. Okay, so let's go over the steps for grouping by factoring. So first you got to check if you have exactly four terms. That's the first step. Once you realize you can do it, split the problem in half or in two parts. I will explain everything when we do the problem. So in step 3, for each part, factor out a GCF. If you have a factor term that repeats, that means factoring by grouping works, and I will explain that. If you don't have a repeating factoring term, then grouping by factoring doesn't work. So just because you have four terms doesn't mean grouping by factoring will work. Okay, and then you will have to use another technique if that doesn't work. Step 4, write out the repeating factoring term only once and bring down leftovers. Okay, so let's do an example 1. So factor by grouping do not solve. So let's see, can we do it? Can we actually do it? Is there four terms? Here's 1, 2, 3, 4. We can, yes, we definitely can do grouping. So now what we're going to do is step 2 is split it in half. So split it into two equal parts. So this is the first part and this is the second, right? So on the first part, bx plus by, factor out a GCF. Can you factor out anything? Yes, you can. You can factor out a b. So this is, if you factor out a b, this would be x plus y. And then the second term, can you factor out anything? Yes, you can. You can factor out a c. So this would be x plus y. So rule 3 says if you have a repeating term, factor term, that means grouping by factoring works. So do we have a repeating factoring term? Yes, we do. The repeating factoring term is x plus y. So if you don't see a repeating factoring term, that means you can't use grouping, and then you'll have to use another technique. So the one that repeats, x plus y, all you got to do is write it out once. Okay, and then it says bring down your leftover. So your leftover is this b and then this plus c, right? So bring that down. You can switch the sides. You could put this on the left, put it on the right. It doesn't matter. So this is your final answer. Okay, so go ahead and pause and write down the work, and we can move on to example 2. Okay, so example 2, it says factor by grouping do not solve. So same direction from example 1. So we have 3a minus 3b minus xa plus xb. So first step is check if we have four terms. Here's 1, 2, 3, 4. Yes, there's exactly four terms, so we definitely can try grouping. Next step is split it in half. So on the first term, 3a minus 3b, can we take out a GCF, greatest common factor? Yes, we can. We could take out a 3. So that would be a minus b. And the second term, negative xa plus xb, can we factor out a GCF? I believe so. We could take out an x. Now, should we take out a positive x or a negative x? I'm going to take out a negative x, and I'll show you why. Because if you take out a negative x, you need an a, and then you need a b, right? Okay, so does this work? Wait. I take that back. We need a minus b, right? Because negative x times negative b will give us positive xb, so we need that minus. So the reason why the reason why, so you know how I said it, you can either take a positive x or negative x. If you took a positive x, then this would be x plus b, right? And this, you want a repeating factoring term, so this wouldn't work because we wouldn't have a repeating factoring term. So you kind of have to like manipulate it in a way. Okay, so we took out that, and then we do have a repeating term. Our repeating term is a minus b. Bring down your leftover, so our leftover is the 3 and a negative x. Okay, and that is your final answer. Go ahead and pause to write down the work. Okay, let's move on to the next one. Example 3, factor by grouping, do not solve. So let's check if we have 4 terms. So we have 1, 2, 3, 4. So we definitely can try grouping. The next step is split it in half. So on the first term, y cubed minus 5y squared minus 5y squared, can we take out a GCF? Yes, we can. We could take out a y squared. And then this would be, we need a y to get a y cubed, and then we need a negative 5 to get a negative 5y squared, right? Okay, and the second term, 8y minus 40. Can we take out a GCF? Yes, we can. We could take out an 8. So this would be a y, and we need a minus 5 because positive 8 times negative 5 is negative 40. Good. So do we have a repeating factoring term? Yes, we do. We have y minus 5, right? So it's going to be, just write out the repeating factoring term. Bring down your leftover, which is a y squared and a plus 8. And that's it. Okay, go ahead and pause to write down the work. And then let's move on to the next example. Okay, let's move on. Example 4. I think there's one more example. So grouping by factoring do not solve. So let's see if we have 4 terms. 1, 2, 3, 4. We have exactly 4 terms. Okay, and then split it in half. So on the first part, 2x cubed minus 3x squared, could we take out a GCF? Yes, we can. We can take out an x squared. And I think that's it. So we need a 2, and we need a negative 3. In the second term, negative 2x plus 3, can we take out a GCF? We actually technically can. It doesn't look like you can, but we could actually factor out a negative 1, a minus 1, right? So you would need Oops, did I made a mistake here. This needs an x, right? Because we want a 2x cubed. So remember, when you're multiplying exponents, you add them. So 2 plus 1 is 3. Okay, good. So this one you need a 2x and then a minus 3 to get positive 3, right? So do we have a repeating term? Yes, we do. The repeating term is 2x minus 3. So just write out that once. And then bring down your leftover. So your leftover is x squared minus 1. Now, you got to ask yourself, is this the most factored form we can factor? We actually can do one more term. We can factor it even more. X squared minus 1 is a perfect square. I don't think I've talked about perfect square yet, but I'll do it in another video. But x squared minus 1 can be factored out as x plus 1, x minus 1, and then you have 2x minus 3. Okay. Okay, so that is your final answer. Okay, and then let's move on to the last one. Example 5, factor by grouping, do not solve. So do we have 4 terms? 1, this is 1 term. This whole thing's a 1 term. This whole thing's 1 term, and then this whole thing's a 1 term. So yes, we do have 4 terms. So we can try grouping, split it in half, or split it into 2 parts. So on the first part, a square m minus b square n, can you take out a GCF? Ooh. No, we can't. So so in this situation, as you can see, you cannot take a GCF. So we could still try grouping by factoring, but the thing is, we might have to rearrange the problem. So over here we have an a square m, and then over here we have a square n. So I'm going to put that all on one side. I want to get all the a's on one side and all the b's on one side because we could factor out GCF. So let me rearrange this problem. Let's rearrange this as a square m plus a square n, right? And then let's get all the b's on one side. So we have a b here and a b there. So you have negative b square n minus b square m. Okay, so now let's try grouping by factoring. So split it in half. A square m plus a, the first part, a square m plus a square n. Can you take out a GCF? Now, yes, now you can. You could take out an a square. And then you need an m here and an n there, right? Okay, in the second term, negative b square n minus b square m, can we take out a GCF? Yes, we can. We could take out a b square, but the question is, should we take out a positive b square or a negative b square? I think I'll take out a negative b square because we need an n here, and then we need a plus m, right? So it would have not worked. It would not have worked if it was a positive b square because this is a repeating. Yes, they are repeating m plus n and n plus m. They're the same thing. It's just they're switched around, right? They're exactly the same thing. So yeah, so our repeating term is n plus n. And then our leftover is a squared minus b squared. Now, is this the most factored it can be? M plus n can't be factored, but a squared minus b squared can. It is a perfect square. I know I don't think I talked about perfect square, but that will be in another video if you want to review that. It'll be made up. It will be made soon. So a squared minus b squared will be factored out as a plus b and a minus b. And then you have this n plus n. Okay. And yeah, so this one's a little bit different because you had to rearrange it in order to take out a GCF. That's something you might have to do, but it works. Okay, go ahead and pause and copy. Okay, that's it. And then the next video will be on a quiz. Thank you. Bye-bye.